Here in section 11.3, we're going to look at solving radical equations. So we're going to continue our discussion on radicals, except now we're going to look at solving equations as opposed to just simplifying expressions. Alright, and so squaring both sides of an equation, okay, so if two expressions are equal, then their squares are equal. So in other words, if A is equal to B, then it should make sense that A squared has to be equal to B squared. Okay, so just an example here, if the square root of x is equal to 4, then the square root of x quantity squared is equal to 4 squared. Okay, and you'll notice what happens here, and this is exactly where we're headed this chapter, or this section. The square root of x squared, the square root of x squared, the square root and the square just cancel each other out, so you have x equals 16 would be the answer to that particular problem. So that's what we're looking at here when we're solving. So when it says solve and check each radical equation below, in other words, solve it and then plug back in to make sure that the solution that you have works. So you treat this just like any other equation. Okay, so you look at the part A here and you're going to say, okay, I got to add 15 to both sides first. And so where I end up is 3 times the square root of x plus 11 is equal to negative 6 plus 15 is positive 9. I got to get the square root stuff by itself, so I divide both sides by 3. And so those cancel. And so I have the square root of x plus 11 is equal to 3. Okay, from there now I got to get rid of the square root. The way I get rid of the square root is taking the square of both sides, and we just saw earlier that we're allowed to do that. Okay, and so what I end up with is x plus 11 is equal to 3 squared, which is 9. Subtract 11 from both sides, and so you end up at x equals negative 2 is your final answer. Okay, and so what you want to do is do a mental check really quick. So when I plug negative 2 in for x up here, I get negative 2 plus 11, that's 9. The square root of 9 is 3. Excuse me, 3 times 3 is 9. 9 minus 15 is negative 6. So I know that I got that one right, okay, because when I plug it back in, it checks. Part B here, again, same process. Add 2 to both sides. So you get root 4x minus 19 is equal to 7. Again, we got to get rid of the square root. The way we get rid of the square root, square both sides. Okay, so I end up at 4x minus 19 is equal to 49. And now, again, it becomes a simple algebra problem now. Okay, add 19, so 4x is equal to 49, and 19 I believe makes, let's see here, 68. Divide both sides by 4 to get x by itself. So x is equal to, let's see here, 1, 7. Okay, and again, just do a quick mental check, plug it back in here. You may need a calculator for this one. When I plug 17 back in for x up there, 4 times 17 is going to be 68. 68 minus 19 is going to be, what is that going to be? Let's see here. I probably should have a calculator handy here, as I just said that you should have one. Not that I shouldn't be able to do that in my head since I'm a math teacher, but my brain's hurting a little bit right now. So I have 4 times 17. That's 68. 68 minus 19 is 52. That can't be right. 4 times 17 is 68. 68 minus 19 is 49. The square root of 49 is 7. 7 minus 2 is 5. Well, that was quite the process there. I apologize for that. My mental math skills evidently are not as sharp as they should be right now. So anyway, that's how we go ahead and solve those, and again, plug back in to make sure that you did them correctly. So just some more examples here. Okay, you have radicals on both sides now. So the first thing I'm going to do is square both sides here. All right, and so all I end up with is 3x minus 3 is equal to 2x plus 8. And now again, subtract your 2x and add your 3 to both sides, and you end up at 3x minus 2x is 1x. Negative 3 plus 3 is 0, so those cancel. 2x minus 2x cancels. 8 plus 3 is 11, so x equals 11. Again, you'll want to plug that back in. On the left-hand side, when you plug 11 in for x, you get 33 minus 3, which is 30, so you have the square root of 30. Plug 11 in here, you get 2 times 11, which is 22, plus 8 is 30, so you have the square root of 30 equals the square root of 30. Should make sense. Okay, I'm going to let you guys do parts B and C on your own. Again, just square both sides and then solve for x. Alright, Example 3 here says solve and check equation with an extraneous solution, okay? Extraneous solution means something, and I'll explain what it means here in a second, okay? So when I go through and I solve this equation in part A, I'm going to square both sides, so I end up at x squared equals 2x plus 15, and now we got to go back a chapter and solve a quadratic, okay? So I pull everything to one side, so I have x squared minus 2x minus 15 equals 0, right? Subtract 2x, subtract 15 from the right-hand side. And so now I'm looking at this, and I'm saying, okay, I got to solve this. There's a variety of ways of solving it. Factoring it is going to be the easiest way if you remember how to factor, okay? Remember, you're looking for two numbers that multiply to get negative 15, okay, and then add to get negative 2. So you have negative 1 and 15, 1 and negative 15. Obviously not going to work. And then you have 3 and negative 5 and negative 3 and positive 5. And I think that when we look at those, the ones that are going to add up to negative 2 are going to be those. And so if you remember, then what we can do is we can factor this guy. We can write this as two binomials. We can write it as x plus 3 times x minus 5 equals 0. Okay, I'm going to run into the next problem here. So kind of hang with me. So in other words, now if I have these two expressions multiplied to get 0, then that means that one of them has to be 0. So either x plus 3 is 0 or x minus 5 is 0. So that means that x is either negative 3 or x is positive 5. Either solution is going to work. Okay, now this is where we get into the idea of extraneous solutions. Okay, we always want to check our answers. Okay, so as of right now, we have x equals x equals negative 3 or x equals 5. So I'm going to plug them in and make sure they work. So when I plug in negative 3 for x, I get negative 3 equals the square root of 2 times negative 3 plus 15. That says negative 3 equals the square root. 2 times negative 3 is negative 6 plus 15. Negative 6 plus 15 is 9, so that's a square root of 9, which is 3. So I have negative 3 equals positive 3. I think we agree that that doesn't make any sense. And so that's the extraneous solution. That's a solution that does not work. We solve it and we get negative 3, but when we plug it back in and check it, we realize it doesn't work. So then when I plug in 5, I get 5 equals the square root of 2 times 5 plus 15. So then I have 5 equals the square root of 10 plus 15. That's 5 equals the square root of 25. And we all know the square root of 25 is just 5. So that one checks. So x equals 5 is my only solution here. Okay? The negative 3 would be called an extraneous solution, a solution that we found but doesn't work. Okay? Part B here, I'm going to do the same thing. So I'm first going to square both sides to get rid of the square root. So I have 20 minus x equals x squared. Pull everything to one side, so I end up at x. So I'm adding x to both sides, and I'm going to subtract 20 from both sides. So I'm going to flip-flop sides here, so I get x squared plus x minus 20 equals 0. Okay, so now I got to try to factor this guy. I get two numbers that multiply to get negative 20 and to get positive 1. Those two numbers are going to be positive 5, negative 4. So when I factor this, I get x plus 5, x minus 4 equals 0. Alright, so this means that x is negative 5, and this means x is positive 4. So those are my two solutions, but again, one of them is extraneous, one of them does not work. Okay, and really the shortcut here is to recognize something. If I look back at my original, this says the square root of 20 minus x equals x. Well, remember from last chapter, the square root of any number will never be negative. Okay, and so your negative root will always be the extraneous solution. When I plug negative 5 up here, this says that the square root of 20 minus negative 5 is equal to negative 5. Well, this says the square root of 25 equals negative 5. And we know the square root of 25 is just 5, and so the negative 5 doesn't work out, and the 4 will work. Okay, and so again, when you're solving these, you got to plug them back in, make sure, identify which one works, and then that is your solution. Okay, and so that wraps up section 3 here for us. Any questions you have regarding these issues, bring them to class tomorrow, and we'll take those first thing.